Hi, this is Lisa. In this video, we're going to talk about the greatest common factor. The greatest common factor of two or more expressions is the product of all the common prime factors, using each factor the least number of times it is used in any expression. To find the greatest common factor, first, factor each term, and step 2, form the product of all the common prime factors, using each factor the least number of times it's used in any term. So I have two examples for you. We're going to find the greatest common factor of 48 and 140. I'm going to use factor trees to do this. You can factor 48 in a number of different ways. I'm going to start by factoring as 6 times 8. Now 6 is not prime, so I can factor that as 2 times 3. 2 is prime and 3 is prime, so I'm going to circle them. 8 is not prime. 8 factors as 2 times 4. 2 is prime, I circle it, and 4 is 2 times 2. I circle every time I ended a prime, and there's nothing left to break down. 48 then can be written in prime factored form, 2 times 2 times 2 times 2 times 3. I had 4 factors of 2 there and a 3. I'm going to do the same thing with 120. Any number that ends in 0 has 10 as one of its factors. 10 can be factored as 5 times 2. 5 is prime, 2 is prime. 12 is 2 times 6. 2 is prime, and 6 is 2 times 3. Here I have 1, 2, 3 factors of 2. So 120 is 2 times 2 times 2 times 3 times 5. I write down all of my prime factors. To find the greatest common factor, I look at how many of these do they have in common. And so my greatest common factor is going to be the common factors 2 times 2 times 2 times 3. Notice we have a 2 here, an extra 2 in 48, so it is not in common. And I have a factor of 5 in 120 that's not in 48, so they don't become part of my common factor. 2 times 2 times 2 times 3, or 24, is the greatest common factor of 48 and 120. If you use your calculators, you do have a greatest common factor program. So on the calculator, if you hit the program key, kind of in the middle of the black keys here, program number 3 is greatest common factor. Hit enter. We're going to type in our two numbers, 48, enter, 120, enter. And it tells me 24 is the greatest common factor. The next example, we have some variables in there. We're going to do the numbers the same way, but we'll do the variables a little bit differently. When you have 3 numbers, the greatest common factor program won't do all 3 at the same time. So oftentimes you want to do either 2 at a time or just look at these numbers. When I look at 12 and 36, I think of lots of different ways they can factor, but 15 factors only one way. It's 3 times 5. And then I can look back at 12 and say, well, what factors does 12 have in common? Does it have a 3 and or a 5? And 12 will factor as 3 times 4. 4 and 5 have nothing in common, so I'm going to stop there. I'm not going to break it down into its primes. I'm just going to find the common factors. And 36 is 3 times 12, so 3 is common to all of those. When you look at the variables, you want to look at the variable that has the smallest exponent, and that would be x squared. And then we're going to break all of the others down to have a common factor of x squared. X to the 5th is x squared times x cubed, right? 2 plus 3 give me 5. And x to the 7th is x squared times x to the 5th. 2 plus 5 give me 7. So I know that I also have x squared in common to all 3 of those numbers. So to find the greatest common factor, we write down what they have in common, 3x squared. That's what all of those terms have in common. When you're factoring out the greatest common factor or writing down all of the factors, the first step is to find the greatest common factor and write it down, and the second step is to group together what is left. So when I break down my expressions, I have a plus sign in the middle here, and I'm going to factor out what's on either side of the plus sign, my two terms. 7 and 21. 7, there's only one way I can factor. It's 1 times 7. And 21 is 3 times 7. Again, when I'm looking at my x's, I know they have the smallest exponent or the least number of x's in common, in this case just x. X squared can factor as x times x. So my common factors are 7 and x. 7x. And in parentheses, I write down what's left. 1 times x is x plus 3. And now my expression is factored. You want to make sure the only place you have a plus or a minus sign is inside your parentheses. Now in example 2, we're given a little hint here to factor out the negative common factor. So when I factor, I'm going to factor out a negative sign. When I look at my first term, negative 5x squared, well, negative 5 is prime, so I'm going to leave that alone. I look for the smallest number of x's that I have, and that's x. And x times x to the 4th would give me x to the 5th. Now 25, I need to factor out a negative, so 25 is negative 5 times negative 5, and x squared is x times x. And my last term, negative 10x is negative 5 times 2 times x. I look at what do they have in common. And I was told to factor out the negative, so I have to take out one negative sign from each of them. I have to take out 1 5 from each term. And I have to take out the 1x that we said they had in common earlier. And then in parentheses, I'm going to put what's left. First term, I have just x to the 4th. Second term, I have negative 5x. And the third term, I have a positive 2, so plus 2. And remember, you can always multiply these back out to check your factoring. Now in example 3, multiplication, x times what's in parentheses, 7 times what's in parentheses. This plus sign that's not inside a parenthesis separates my expression into the term on the left and the term on the right. When I look at them, the things inside parentheses are exactly the same. X plus 5 is my common factor, and if I look at what's left, I have x plus 7. That goes in a second set of parentheses, and that expression is factored. And that concludes the video on factoring greatest common factors.